and we could say that we start. I stop this one, and we welcome Semantum, Cadmatic and Draga to this presentation, and we will divide the time in two slots. First Semantum, Cadmatic, and then the second slot Draga. So welcome Gerardo and Jim, and maybe some more, I don't know, to start, and you can take over the presentation mode.
Hello, Eric. Thank you. And hello, everyone.
So
start sharing my screen, Jim, if that's okay. We can, and then you take over that. Yeah, great. Hello, good morning, everyone. Yeah, very happy to be here, and thank you for the invitation. We're gonna be presenting this case together with Fortum, related to a customer case that we had together with Fortum. It's an energy company, as you will. And most probably you already know it, but you will learn some things about Fortum today. Yeah, hello. So this is me. I'm Gerardo Santillán. I'm a senior specialist at Semantum, and I will be presenting together with Jim. Would you like to introduce yourself, Jim?
Yeah, Jim Nurus from Cadmatic, sitting in the headquarters of in the city of Turku in Finland. Right now, sitting in a Scandic hotel in Luleå. And I have two roles. Currently, I'm taking care of all the Swedish customers and our sales here in Sweden, but also, as the title says, technical account director. So I'm helping our sales to find new customers, and when they are found, I help those customers to get the best out of our solutions, and also being in contact with our development people to forward requests from the customers and markets how to develop our solutions further. That's me.
Thank you, Jim. Yes, and I am a senior specialist and sales manager at Semantum. Have been involved in different things related to modeling, simulation, and also this engineering automation, which is precisely the topic that, at least from Semantum side, we are speaking about. Happy to meet you all, and most probably we have met at some point face-to-face with many of you. Jim, yes, some things about Cadmatic.
Yeah, Cadmatic is a software company, origin from Finland, more than 40 years of activities already. We have offices globally, about 17, where we have the customers, close to 50 million euro revenue, so about 6,000 customers. And today we are about 340 people in total in our organization. So quite international customers, and as you see below there, so huge companies, not only from Nordics but also globally, including like Saudi Aramco, for example.
Thank you, Jim. And we are Semantum. We are a software development company. Also from Finland, we are in Espoo, which, as maybe you know, is part of Helsinki metropolitan area. And we have different focus areas. We have a strong background in modeling and simulation. We develop and maintain modeling and simulation tools. But we also started developing during the last 5 years these engineering automation solutions, which are for data extraction of design data from legacy material. And then we also create engineering assets automatically from the data that we extract. We have multiple backgrounds in the company. We are software developers, but we also are modeling and simulation experts, obviously. And we have also a strong background in mathematics and physics. Here are some of our customers. These customers are mostly related to modeling and simulation. I will show some success stories of our engineering automation side later when I describe the solution. And we have been also collaborating with Cadmatic for the last, for maybe 5 years, 6 years. And this is the case for this specific project that we're going to be presenting today. But before we go into the actual project, we would like first to give some technology background by giving some introduction to the tools that we have been using to help Fortum in this specific case. This is the agenda that we will be following. As I mentioned, some background technology. We're going to show model broker, Cadmatic, then the Fortum case itself. What was their challenge, and then their plan to solve it, and then how we help them using these tools, model broker and eShare, and then benefits and the summary of this presentation. Well, yeah, the first thing I would like to start is by introducing this model broker for diagrams. Model broker is a family of tools that are focusing on extracting data from available design material in process industry. We have also been working a little bit with electrical drawings, but we are mostly working with PNIDs. In the process industry, there's a big need to extract data, to access data available in technical drawings. And it's not only about creating or just extracting the data, but also making it available in a format that can be consumed by digital applications. And now that we are also in an era where AI is used extensively for many applications, it's also about presenting this data in a structured way, machine-readable way, so that we can enable these AI solutions. Now, the big problem here is that most of this data is available in technical drawings, so these legacy drawings that many times are available as just scanned drawings, but many times it's also possible to get access to it in other formats. But nevertheless, it cannot be used by digital tools. So obviously accessing this legacy data is very important, and not only it's accessing it, but it's also accessing it in an efficient and accurate way, so that we can take advantage of this, since there are many applications for which it can be used. And this is what we have been developing in Semantum. We have been developing this model broker for diagrams. The idea of this tool is that we are, as I was mentioning, just getting technical drawings, then processing them, configuring them, and then creating machine-readable files automatically, so that we can use them as an input for different digital applications. We work a lot with PNIDs, but we also have a lot of experience with control logic diagrams and also electrical diagrams. The only difference here is the type of output that we produce. When we are speaking about PNIDs, we produce DXP, XML. DXP is a standard way of representing these intelligent diagrams, meaning that in this XML that we produce, we get information from the actual graphics of the PNID, but also all the objects, its attributes, and also the connectivity of all the elements in the diagram. So it's a pretty thorough way of representing these drawings. With this model broker, we support the latest version, which is DXP 2.0. We also support previous DXP 1.x. But DXP 2.0 is enabling us to also create knowledge graphs from the data available in the PNIDs. More specifically, this RDF format, which is the DXP community has been focusing on developing direct mapping from the classification of DXP into this RDF graph representation. And we also create tables from the data that we extract from PNIDs. Depending on the type of customer, we change the content and the structure of these tables. When we speak about control logic diagrams, we can create also PLC OpenXML. That's also another application that we have, or export format that we have. Over the years, there are many things for which customers would want to extract the data and make it machine readable, but the most common still these days is to create intelligent diagrams. And we are enabling this workflow by first configuring all these diagrams, extracting all the data, and then using DXP to then import it into existing CAD systems. In this specific case with Fortum, we have been doing it with Cadmatic PNID. There's also eShare possibility to import that data into DXP. That most probably Jim will discuss it later. But we are also capable, because we are using DXP, we support also other CAD tools, not only Cadmatic PNID, but most of the major CAD systems are now also supporting DXP. But this is the workflow that we follow here. I will show a video where we are showing how we do this data extraction, specifically into Cadmatic PNID. These PNIDs that I'm showing are example PNIDs, but I think they are quite representative of what one would find in real processes. The workflow in Model Broker goes in a way that we start configuring these symbols. We import the diagrams. We can browse through the diagrams, take a look at everything that is there. We can select the graphical primitives of the certain symbols, and then we configure different options so that we can be general or very specific with this. And very important, we map these graphical primitives of specific symbols to specific DXP classes, and from there we can then cover the entire diagram and export all the results from it. You can see there now in the video how all the different elements in the diagram are found. We can find symbols, text, also connectivity is found automatically. When we are creating intelligent diagrams, we export this as DXP, and then we also have visualization tools. As you can see here, this is the XML that was created directly from Model Broker. You can see there how connectivity is found. Here, for example, we can manage different OPC connectors. We can see all the elements and the attributes that are available in the diagram. We can browse through different things. And then when we have the DXP file, we can then import it into Cadmatic PNID. This is the Cadmatic PNID part, where the configuration wizard is allowing the user to import these DXP diagrams. There needs to be first an initial configuration where the user is mapping the classes available in the DXP file to the classes and the symbols in Cadmatic PNID. This configuration wizard has been developed by Cadmatic, and then it enables this a more efficient way of then just importing these PNIDs. It has to be done once per project, and then after that it can be then generalized for all the set of diagrams from the same source. We will eventually see how we do this. So if we think of how this is done, that it's basically a generic drawing, just a PDF. This was the source of this specific example. And then after importing this in Model Broker and creating a DXP file, then we have here the possibility to access the intelligent diagram with all the objects, all the attributes. You can see here how we can obviously edit these diagrams now in Cadmatic PNID, as Cadmatic PNID is an authoring tool. We can add certain attributes to the specific objects that were coming from the XML that Model Broker created. So it's really the entire workflow coming from the technical drawing into the intelligent PNID. And we're enabling this with DXP and Model Broker and Cadmatic tools. This specific PNID then later can be imported into eShare, but also direct support to eShare is also, the direct import into eShare is supported. Another very important thing, and maybe this is not so related to this topic today with the Fortune case, but it's important to tell, it's very common these days for us to get the request to create knowledge graphs. Now with DXP 2.0, we were also doing it already with DXP 1.x, the previous version of DXP. But with DXP 2.0, now we have direct mapping of many classes into RDF representation. So that's what we are doing. We create knowledge graphs directly from the DXP files that we create after extracting data from the diagrams. And there are many applications depending on the customer. Process copilots is very common. Then decision support systems. There's a semi-automatic way of doing HACCP analysis. This is something that we're also enabling. Quality assurance, anomaly detection. And of course, even process optimization is an application for which some of our customers are using these knowledge graphs. And we are able to produce it natively from Model Broker. And of course, we can create lists, especially EPCs. Well, not only EPCs, also owner operators. But EPCs, for example, are after material takeoff lists. Then owner operators, when they want to also integrate their data into, for example, eShare is a case, so digital twin applications or even ERP systems or maintenance systems. They're also requesting instrument lists, pipeline lists, or tag-to-tag lists. These tag-to-tag lists are lists that include also connectivity there, and we can create them with Model Broker. Some other workflows that we're enabling, creating simulation models, comparing 2D and 3D models. Even just a visualization of the DXP file is important in cases in which different stakeholders do not have the same CAD tool and they want to share information. That is important. Creating knowledge graphs for AI applications, and of course, as I was mentioning, and as it was in this 14 case, we are creating intelligent diagrams from available material. We have with Model Broker high coverage, up to 100% coverage of all the material can be, or all the elements in the diagrams can be then translated, mapped, and then put into machine readable files. The validation of these results is way thorough than with any other AI method. For example, we are not using AI for the specific translation of these diagrams, and that gives us a lot of advantages. We have customized outputs like the XP and XP 2.0, RDFs, or different lists. And this is not based on AI again, so any person with process or automation background can use the software. And this is an important differentiator with our software. This is a software tool that can be delivered to our customers, and then you can start using it without the need of this being a service. This is very important when it comes to, for example, when there's no possibility to share diagrams. We can also do the configuration as a service if needed, but it's also it's very common that our customers need to use the tool themselves. Here are some of our customers. AFRY has been using Model Broker for some time. Also, Sweco has been applying Model Broker for creating intelligent diagrams for available from legacy material. Right, this was the introduction to the first part of this technology background. Now I think, Im, you will give us an introduction about eShare.
All right, we'll be done. So I will steal the screen here and put the presentation running here. So first shortly about Cadmatic and eShare introduction. So just need to remind that Cadmatic is much more than just eShare. So we have the full portfolio for design and engineering, 3D, piping, layout design, electrical, HVAC, and PNIDs, and all kind of different data management, information management solutions, including the eShare. So we can provide full portfolio of tools to cover the whole life cycle of a plant investment. And when we come to eShare, so here are a couple of companies we are working with, who we helped in digitalization and who will give us pressure to develop our solutions further. So such a giant from the desert, Saudi Aramco, they have more than 200 units already in our eShare, part of the operations maintenance. ENI, Repsol, energy companies from Mediterranean. Sumitomo, a previous Foster Wheeler, they are using our solutions. Shipbuilding, all the ships which are floating out from Turku shipyard, the world's biggest cruise ship, so they are all designed with our solutions. In the Nordics, SCA, UPM, Stora Enso, Metsä, they all have at least in one of their plants eShare up and running. Consulting companies like AFRY is using Yara facilities. In Sweden, LKAB, Fortum, in Finland, Viscaria in Sweden, Nouryon, they have our eShare in use. So we get a pressure to develop our solution further all the time, and we are happy to serve these customers. Then why eShare? So first thought about the eShare is the integration. So you need one place to access all project or plant data, a digital twin platform, an integrator, a hub, whatever you want to call that. Baby has so many names. And by using the external data and internal data from the documents and from the 3D model, so we can create different kind of visualizations to give a fast and rapid understanding about statuses, situations, bottlenecks or problems can be found otherwise in the list format, but from the 3D model as a visual appearance. Share part of the eShare is to improve the communication, collaboration, so everyone is looking same data, same model, same point clouds, can share their ideas, thoughts with markups, smart points, and so on. So it's also a collaboration tool. And these were the reasons how we started with Fortum. The first came this eShare thought. So we put eShare somewhere in the middle, integrate that one with the documents, drawings, document management system, or just files, no matter for eShare. And with different kind of adapters, we integrate eShare to the maintenance management system, process historian systems, Excel sheets, any kind of databases which has a relevant information which a eShare user want to see in connection with the 3D model and the documents. Instead of explaining more, so I play here a short video about our capabilities which made Fortum interested in our solution. Here I have started eShare, and it is connected to the process historian, so there are a couple of main equipment and their terms. There are some markups for the communication purposes, status information of the project and piping manufacturing, and also direct link to IBM Maximo database. And from there we find out that there are 803 operating objects and 9 inactive objects. And that makes me wonder what this is all about. Here I fly through the model, and as you see, we can take the point clouds and the 3D model both together at the same time, place them correct according each other. And here I choose one of the pumps. Okay, 012, some information from the model, some information from IBM Maximo database straight here. And there we can see that that is one of the operating objects. Another pump, again, some data and data from Maximo database about that pump. And we see that this is one of those inactives. All right, I want to know more. So I choose the visual styles. I have plenty of them, but for this purpose, I choose Maximo status categorization. Now this status is just an example of many different possibilities, like objects which has an open work request or whatsoever might be in your interest. So now we see blue ones operating, red ones inactive. I can have also hierarchy for same one. So I can choose from a hierarchy list what are those inactive objects. Of course, this information can be used also for the reporting purposes. And since I have a 3D model and visualization tools in use, so I can use those ones as well. So if I switch the operating object away, and I can activate any kind of objects or object groups here straight to give you a better idea, whatever is in your interest. All right, I choose again the first pump, and I want to see where it is in the PNID. So as explained, so we can connect eShare to the documents or get the published documents from Model Broker. And here is the PNID where we can find those pumps and other objects. So if I choose the filter, so again, some information, and I go back to the document, so the filter is there in the middle. This is very handy when you have in the pulp and paper industry, you have those 9-meter long PNIDs to easily find objects there. So that's very handy. Valve here, some data from external sources about that valve list, documents, drawings. Here is the isometrics of the pipeline where that valve is found. V923 is there. We could pick up those spool drawings, but I go back to the model by clicking the valve, another valve, and so on. So this is how we link the documents and drawings in eShare. So it is using the tags and attribute information and then you can toggle from 3D model to any document where that object is mentioned. All right. Blues and red ones. Then we continue with the PNID. In this case, in this eShare, so green are objects which are in model, red ones are which are not in model. But I can change also here the coloring schema, the matching the coloring in the model. So remember the pie in the beginning, blue ones operating, red ones inactive, same in the 3D model, and now same in the PNID. So any kind of property which makes difference between the object or object groups can be used for this visualization, and not only in the 3D model, but also in PNIDs. So even here, a dummy PNID becomes a valuable source of information, any kind of information that you can link there. And of course, you can have these both open at the same time to enable better research of the model compared to the PNID, finding the objects and locations. Yeah. And this has been appreciated by our customer very much. And this was also one reason why Fortum invested in eShare, to be able to view the PNIDs as this way. So red and blue in the pie, red and blue in the model, red and blue in the documents as well. So let's switch off this PNID and take something else. Again, I pick one of the pumps. And here I have, besides I get data from Maximo. So here is the link to Maximo. We have done this in cooperation with Nexer, who is an IBM consulting company, active also in Sweden. And now I'm totally in the Maximo interface. I switch off the eShell, and I might be a maintenance engineer working with Maximo, looking for the same object, the P011 pump. I go to the location. I could add work request for the pump and whatsoever, search for information changes. And if I want to know where that is, I can click always view in eShare. I click that button in Maximo. That includes the command open eShare, open project, open model, and find the pump. So here I have the pump then, and I can continue working in eShare. So this was a short introduction about the capabilities of eShare, which made Fortum interested in our solution in the first hand. The first department of Fortum, what we are talking with, is the heating and cooling. So they are providing district heating and probably district cooling as well, and use different kind of modern systems with emission-free machinery, so heat pumps, heat storages, and so on, to produce the district heating. And at the first stage, they have about 30 production units around the city of Helsinki, and all those production units will be in eShare. 3D models, point clouds, and a combination of them. And when they started the process, so this was the picture. So they have already Maximo as a maintenance management solution and different solutions, PNIDs just as a plain drawings, and a storage where they had some point clouds and 360 images, separate 3D models from plants, and then of course documentation. They wanted to improve that one, and they started the Asset 360 project. During the project, they evaluated different tools, including some tools which could offer something like Cadmatic eShare, but at the end, they were convinced that eShare is the right solution for their tool, for their Asset 360 project solution. And at the same time, they decided to switch from the drawing-based PNID management to a database PNID management, and that was mostly because they were introduced for Semantum and the model broker, so that all those PNIDs of all these plants, which are in different symbol libraries, different systems, a bit slightly different naming rules, fonts, and so on. So after this exercise, when Semantum is converting those PNIDs to Cadmatic PNID, they will look exactly same, have the same title box, have the same symbol library, same standard, and one place they are managed, and that is the database Cadmatic PNID. You may want to say something about this, Gerardo.
Thank you, Jim. Yes, I think you already described a bit about this. We were helping in this case by configuring these diagrams, extracting data from them, and also helping on this data harmonization so that different tag names would be having the same naming convention. And then what we did together with Cadmatic, we were helping also importing these diagrams into Cadmatic PNID so that later they could be also included into Cadmatic eShare. Yeah, I think that was our involvement there, and I think you can continue now with the with the rest of the story. Yeah,
I will do. So this was a Fortum diagram when we started to solve how to do these things, and you see the principles here, what has been explained in one picture. So we already used those 1,000 words to describe this one picture. And the data model infrastructure at Fortum in this case looks today like this. They have the Maximo as the main maintenance management solution, and they have the M files for document management. They are linked to eShare, which has the 3D models, point clouds, 360 images, and also linked with the PNID so that they are intelligent and linked with the 3D model in the way what I showed at the video just a while ago. So what they wanted to reach? They wanted to reach a good quality and accessibility because of the safety, and they also, during the same time, they of course review the PNID so that they are correct and all the changes are implemented there. If there are something what they are not able to trust, they go to the plant and check the real situation, and update models, update the PNIDs, and so on. So that's a safety issue, that the information matches the reality. Then helping the maintenance people, they get an alert that something needs to be repaired, where that is, where are the documents, where are the information of that one. Access also to the 3D model. If you locate it first and then need the data from maintenance, you can jump to the maintenance, get the information there, and so on and so on. There are unmanned plants, part of those ones what was in the list, so that the maintenance crews can go first to one plant and then to the second plant. So it's vital that they have a pretty good view about what they are going to do before they access the plant. And the benefits, well, it's kind of obvious, but we might find that what Mr. Harri Ranta here, who was in charge of the project technical manager, explained, we were very rapid to set up this system. So in a couple of weeks, the first setup was up and running. And now they really can have access to the data and information, no matter where the users are and so on. There is a full story available of this one. So the summary, the challenge what they faced was that the technical data was scattered. It was different silos. Systems were disconnected. There was no integration between systems. It was time consuming that when you need to open 3-4 different systems to find all the relevant data, and when something is updated, the other one doesn't know about that one. So the usual story of with the legacy data and plants which have been up and running for a while already. And Semantum and Cadmatic together, we helped with the model broker to make a sense with the process data from the PNIDs and making them intelligent and enabling future use in a document-based, database-based system instead of just drawings. And then, of course, eShare connecting their other systems together to provide collaboration platform, digital twin platform for plant data. We are still in the beginning with complete Fortum, but even with this first step with the heating and cooling, so there are plenty of things what we can start to develop, like isolation planning for the maintenance task and so on. So there are plenty of things what we can improve to help Fortum to improve their business. So that was that, and at the end, so I hope. And that was quite what I intend to present, and I'm extremely surprised that we didn't exceed the given time. So we have a couple of minutes if someone wants to put a question, so happy to answer. And if you want to know more, so you know who to contact relating the topics what was presented. So me and Gerardo are ready to answer your questions and give demonstrations, presentations, and looking at your situation, how we can improve and help you. Thank you.
Yeah, I have a question, if possible, then. Andreas Bertis here from Stora Enso. And I think this one is for Gerard, I believe.
Sure.
You showed an example here with only PDF as an input for the model break. I wonder, are there other available formats also? For instance, the normal common digital like DVG or DXF as an input also, because we have a lot of such drawing that has been deviated over time, used by different consultants, and they are not blocks or editable. It's just a visualization of a chart.
Surely, yes. DWG, DXF, DGN, those are very good also for model broker. Those type of files. If there was a case that there's a scanned drawing, for example, we can also take a look. The only difference is that we would need to take that as a service. But these formats that you are mentioning are quite suitable for this model broker. And even DWG, when they include block information, is even better. Configuration can be way faster, yeah. So, yeah, happy to discuss this also.
Good, thank you. All right, some more questions?
All right, thank you for your time and interest, and we pass the ball further to Gaute, I think.
Yes. Okay. Thanks.
Should we take a short break? So we,
Yeah.
I think we could, maybe we should need a little bit break, but could we take a break to 9:43? That's a 3 minutes break on my computer.
Very good.
Okay, then we have passed the break. So welcome, Gaute, to present.
Thanks a lot, Erik. It's an honor to have this opportunity. So with me today, I have Alexander Koshnikov. He will do the live demo of the presentation. He is head of development. My background is I worked with oil and gas for the past 25 plus years. I've stopped counting. And I worked with large oil and gas companies because we are based in Norway. Yes. So I posted 2 links into the chat. One link is to our webpage, draga.sg, and one link to the new software solution, MIMSTech. The way I want to do this, I had a discussion with my AI assistant, and that created a nice speech for me. So I'm going to read out that, and then we can go into a live demo, and then we can open for questions. So Draga is a consultancy company that works with technical engineering information management. Draga is owned by the employees. We have offices in Stavanger, Sandefjord, and Thailand. In Thailand, we work with high volume engineering drawings to make them digital in a cost-effective way. We have very long experience from oil and gas industries, and most of our people have worked with that work with us are discipline engineers, and we are not an ordinary IT company. We are experts in engineering, data, and advise large companies such as Aker BP, Equinor, Aker Solutions. We are also the one that created this IMF standard that we have been up here several times, which we develop on behalf for PCA in Norway. We sit on the board for the DEXB organization, and we represent the big oil companies in DEXB. I would also like to mention that we have been working with Semantum for a very long time. When we look at today's major industry projects, whether it's oil and gas, the process industry, or the green shift, there's one resource everyone is talking about, and that is data. Data is the new oil, it's said, but the truth is that it's far too many projects we behave its data is something to be locked down, hidden, or protected in proprietary formats. We all know the story. A huge EPC project is completed. Billions have been invested. Thousands of engineering hours have gone into building complex 3D models, PNIDs, and equipment databases. But what happens when handing over to the operator? The data is delivered in PDFs or in closed vendor-specific formats. In practice, the operator inherits a digital prison. If they are to make changes in 5 years, they are locked into the same software supplier and the same expensive licenses. This is called vendor lock-in, and it costs the industry billions in lost efficiency gains every single year. It slows down innovation, makes digital twins venture unnecessary complex, and create unnecessary barriers between engineering disciplines. This is exactly the problem we at MIMS Tech have set out to solve. By setting the data free, we don't just solve the interaction today, we make the project machine readable and ready for the AI revolution that is sweeping over us now. So if you now I want you to go into this mimstech.com link. You can see the software there. So what is MIMS Engineering Suite? MIMS Engineering Suite isn't just another design tool. It's a modern web-based API-driven.
You are not sharing your screen, just so you know.
No, and I'm not. I just want you to go on your own and just have a look while I talk. If that's, I posted in the chat a link. If that's okay. Yeah. So MIMS Engineering Suite isn't just another design tool. It's a modern web-based API-driven engineering platform built from the ground up to put the data and not the software front and center. We did not start from scratch. So MIMS was first defined by Statoil or Equinor all the way back into the 1980s, actually. So it has been, it's actually a very old software, but we have taken over that software and make it modern in a web format and put also a lot of new functionality into the system. So traditional engineering software has been silo-based. We buy a huge package. Everything is stored in one internal format. Often the engineering package are also divided into separate programs for each engineering discipline. A tool for PNID, a tool for instrument, and a tool for telecom, which does not talk to each other. MIMS turns this on its head. With MIMS, you get all the engineering disciplines in one integrated package. Our architecture is open and API-based. This means that all the data generated in MIMS, whether it's a process value, pipeline, attribute, or cable diagram, is immediately available to other systems and standardized interfaces. Important principle, you own your data using MIMS. Everything is created structured in our database and are accessible via APIs and standards. If you want to use MIMS to generate your engineering design, but want to use a completely different tool for advanced analytics or predictive maintenance later, then the path is open. No hidden formats, no hostage taking of your project data. MIMS and Engineering Suite also works very well with middleware. We have direct integration, especially to Hexagon Octave, SmartPlant. Many of our employees have a background from Octave or SmartPlant, so we know the system very well. And we also have integration with Aviva, especially on the 3D part. Often direct mapping between systems is much faster and better solution than going via third-party standards such as DEXB. DEXB and international standards. In particular, I would like to highlight DEXB. For those that work with process design, you know that the P&ID, the process and instrumentation diagram, is very the nervous system of the plant, yet historically it has been nearly impossible to move an intelligent P&ID from one software system to another without losing its intelligence, relationships and metadata. You have ended up redrawing things. It's waste of time and it invites human error. MIMS fully supports DEXB standard. So what does this mean for you as a customer? Seamless integration. A subcontractor can work in another DEXB compliant tool and the data flows straight into MIMS with no conversion loss. Future-proof handover. When a project is handed over to the owner operator, they can get an intelligent live data model in an open format. They can plug this data directly into the operating system or the digital twins. Risk reduction. By eliminating manual punching or insecure mapping between systems, we remove one of the biggest sources of error in early phase of a project. DEXB is our guarantee to make the MIMS does not build walls, we build bridges. MIMS is very flexible and easily to configure against other standards such as GeForce. The system can be configured by uploading config spreadsheet, so you can define standards like GeForce in the spreadsheet. Okay, only one page left. Let's look what this means in everyday life for a company like Saya and their partners. When we combine this open architecture with MIMS integrated engineering suite, we blur the traditional distinctions between disciplines. The process engineer who define pipes and valves, and the electrical engineer who design the power supply, and the automation engineer who program the control system, are in reality working in the same living computer model. When a valve is changed on the P&ID via the DEXB import, the equipment list tag database and associated 3D model are automatically updated. We call this true interoperability data continuity. Secondly, the API-driven nature of MIMS makes integration with existing ERP, PLM or maintenance systems such as SAP or Maximo more routine job rather than a monthly long IT nightmare. The data is clear, structured and cleaned according to the standards. So the future is open. The industry is facing enormous challenges. We will build faster, more efficiently, and we will operate the facilities with minimal climate footprint and maximum uptime for preferable 80 years. Are we to succeed in this? We cannot afford to waste time on property dead ends and companies protecting their own licensing model on the expense of the project's process. MIM's engineering suite is designed for this new reality. By setting the data free, by providing a full-fledged modern engineering suite in the web, and by anchoring everything we do in open standards such as Stexby, we give control back to those who actually own and build the project. We at MIMS want to challenge the established. We want to show that the most powerful software is not the one that keeps secrets the most, but collaborates best with the outside world. Yeah, so that was my AI written document. So I hope you could follow me. I think it was quite spot on for this topic. And now we can go into the actually software, Alex.
Yep. So what are we going to show today is mostly our demo portal. We also can share the current MIMS development state. So Gaute, do you have any ideas what we have to start from?
Yeah, we can maybe start with the loop diagram.
Yeah, so again, MIMS, or it was called CAPSYS or EIS, which is quite known in the world before, was started development about 45 years ago in early 80s. About 5 years ago, we bought the source code. And good for us, it is based on very good database, which contains all the data, all the possible engineering data in all possible disciplines. So it's quite well developed for the last 40 years. And the only really missing part was the interfaces. So interfaces was typical Windows XP. And this is what we started to do. We rethought, we rearranged a lot of things, and now it's now we will show the most interesting part of it. One of the biggest issues in the industry, as far as I know, was loop drawings. It takes a lot of time to populate data to generate it, but now just based on a single source of database, we can generate it in milliseconds. And now you will see the drawing which were generated. So this is non-existing drawing, and it was auto-generated just based on the data in database. So you can see how quick it is.
Yeah. So there is no PDF there. So if you want to have a PDF, you can save it as a PDF. But the idea is that everything is generated on the fly based on data. Yeah, and that also means your data need to be correct.
And actually, this is one of the best way to see if the data is correct. You just open the generate drawing on fly and see if everything connected, and if everything is fine, then data is fine as well. Now the study is quite similar type of drawings, block diagrams, which represents mostly lightning, but some other parts as well. We have a huge database from Equinor. And again, all drawings here are auto-generated. And probably I forgot to mention, we are doing web-based tool. So there is no installation. You don't need anything on your PC except web browser, like this one. Just open browser, follow the link and log in, and you're inside the tool from any part of your world. This is the block diagram, very typical. Another types of drawings, connection diagrams. It's here we decided to go out from classical diagrams, but we can generate DVG or PDF from out of it as well. But here you can see in live what's going on with your boxes, with your fuses. You can see what's the available fuses, terminals, etc., from here. And it's very easy to see even the live data from if you have it in your system. Single line diagrams, also auto-generated drawing. The thing you will see now is not the very classical single line diagram. It is Equinor style. They really want to see the details, and since database contains all these details, we can present it in a nice view. But then we know about industry's needs. We started to play with PNIDs. PNID is not auto-generated tool for sure. Engineer must place the drawings. And here you can see the very classical DEXP drawing. You can find it on dexp.org in their blueprint files. This is very typical PNID, which contains PNID drawing, which contains almost everything what's possible to see on PNID drawings. And here we started to play with our graphical engine. And very first thing we ask ourselves, what we can do with this data. Yes, we can present the drawing, but everybody can. So then we find out that we can control this drawing not on a graphical layer, we can control it on a data layer. And the very first simple example, what we can do is just to switch off color of the drawing. Here it is. So basically what we did now is that we didn't change the drawing, we just changed the way how we want to see this drawing. And this is one of the key part. So we do not modify drawings at this level, we just change the view and change the way how we want to see the drawing. I'll put next thing we were doing, we decided, so if we do not change the drawing, so what else can we do and how we can enrich the data on top of it? So this is what we made. We did a review module. So here you can see all the changes, all the elements, all the symbols, all the equipment which were modified during some sort of period were marked with the colors. And here we can interact between engineers. We can ask questions, we can approve or disapprove some changes, and we can see the changes. That's the important thing. So we can control this drawing on a data level, which is quite important in engineering. Another big improvement was to add commissioning packages on top of the drawing, because we know that currently in almost all companies, they print the same drawing in 10, 20 times, give it to different engineers, and engineers manually do some markups on top of the drawing just to make commission packages. I've seen hundreds of these drawings, and it's awful, honestly. But now you can do this online based on the very same drawing. So you don't need to print it, you don't need to do anything, just draw it on top online. You don't need anything else. And everything will be stored in a single database. So I guess those of you who was working with commission packages, you see it. Of course, we have red line markups like this one. It's also quite useful thing for those who's using it. But then we were asked by one of the clients, so can we generate PNIDs? So before I was saying that we need engineer who was supposed to place the symbols at the drawing, connect symbols, etc., etc. But now basically just based on the data in database, we can regenerate the same drawing in the graph view. This is what I'm going to do now. Yes, that was auto-generated drawing, just based on a graph theory or just a lot of math inside. It's pretty much same as you can see, but what it gives to us possibility to connect drawings or different drawings into one big or huge PNID. For example, here you can see OPC symbol. Let's generate one common drawing. Yes. Now you can see basically two
So
drawings.
I've heard the engineers are are printing out PIDs and putting tape and putting them together on a big floor, and
yeah.
So this can be solved in a digital way if you have a lot of PIDs connected.
Yes, and again, all this information in our database means we can simply auto-generate PIDs like this one. We can generate PID just for one system or just for one pipeline, doesn't matter. It's, again, as I told before, it's we or you decide what you want to see. It's very flexible. But this engine is quite old, so we already built a new version with this. So what I'm going to show now. Gauta was saying a few times about DEXP. Yes, we are at the board, or we lead DEXP initiatives on behalf of Equinor, lead in DEXP initiative in Norway. That's why I know this format really good. Now, yeah, so this drawing was generated from the DEXP schema. It's a bit more advanced than classical DEXP one, but here we can show some funny parts. For example, we have AI assistant, which works really simple way, but really nice. And again, since we can control drawing and everything what's inside drawing on a data level, not only the graphical, but also data level, we can do some funny things like ask AI assistant, what is it? Yeah, and this is process shutdown device with a lot of explanation what it does, but the most important thing that it have associated valve, and it is highlighted. It's pointed here as a link. We can straightly jump into it. We can ask something else, for example. So now I just asked to show all PSD systems the drawing, and here it is. We have 3. And again, it's probably not that necessary for engineers, we know it. But it shows the possibilities. It shows the really nice things. You can interact with, at least with the quite complicated, and this drawing is not really complicated. I've seen way more complicated ones, but just ask AI, it will guide you and it will point you what you have in this drawing. Another thing, at least I'm not sure how it's in Sweden, but in Norway we have working with SCD drawings, and here we can show some possibilities what we can do with the SCD drawings. So now if you see now, I just loaded AML schema, which contains SCD drawing. Then on background, it connected data from the AML file with the DEXP file, and now we can do some really nice things like this one. So we can project data from SCD file on top of the PID. So we call it hybrid drawings, and I guess nobody else can do this yet.
Yeah, all companies in Norway are at least very interested in this one.
Yes, yes, we see huge potential and a lot of interest to this particular thing. So here we can see that our PST devices controlling, controlling motor here. Or for example, this is how this set of valves connected to this one. So it's very easy and simple manner of showing data on top of it. Of course, as Gauta already mentioned, we have a lot of nice things like IMF. For example, I will select this pressure transmitter. No, this one possibly. I don't really remember. Yeah, this one. And here you can see probably a thing which you've never seen before. We injected, or we split this temperature transmitter into IMF blocks, and each block contains information. Here we can simply connect it to external sources. In Norway, it's quite well-known EQ hub. This is the data source for many equipment. Yes, it was 15. And now system read all information about this device from the shared catalog from EQ hub, and you can see data is here. Yes. We also have interface to 3D tools. For example, we have interface to Aviva E3D. And this is a very simple sample about SegNet drawings. So basically, we read information from 3D system Aviva E3D and generate the light projection of the cable trace from that system, together with the cables from our system, from our database. So here you can see this projection with all possible data, with the length of the lines, length of the cables, etc., etc. You can even see the cables. Here we have some test one. Yeah, here it is. So this cable goes from this node to this node, or opposite way. Doesn't matter. We were also playing with the brownfield commissioning. We made this interesting tool which basically shows what's happening with the drone at its life cycle. For example, here you can see again and again the DXP blueprint file, but it was developed through some steps, and here you can see the steps. So from revision 1 it was developed to revision 2, which was shown like this one, and you can see the changes in the title block. But the most important part and the most interesting part, how we reached the state from revision 1 to revision 2, and here you can see all the middle steps, what was going on. And again, it's all based on our database. So database contain all this information. That's why we can highlight, we can see, and we can project it at the graphical level. So this is what was happening with the drawing until it became revision 2, and of course title block also. I can also show our current state of the development, as we mentioned again before and before. Yep, we also almost finished on our Eric.
Yeah.
I can show the interface of our MEMS solution, which has dramatical change from the Windows XP view. So it's again everything online. You can see all the data. You can see it in a way of Excelish style. So very simple way. You can take your Excel and do multi upload if you want. You can export everything into Excel. So every single discipline has this Excelish style windows. Or if you want to see some details or more user-friendly, just open another panel and you can see it here. So for every single element, it has its own information.
Yeah, so a lot of feedback we have is to reduce the number of mouse clicks, because
yes,
people are
yes.
getting sick of clicking for just to reserve one tag, and so you can mass reserve tags there. And,
yeah, here you can see all the disciplines which MEMS support. So basically, I don't know if we're missing something. I don't think. It's everything here, including management, procurement. Basically, it's everything, and everything in a single source database. Everything available online. You don't need to have any other tools, and we can generate all possible reports out of it. And skies are the limit. I think this is it what I wanted to share today. Gaut, if you can continue.
Yeah. Thanks a lot, Alex. And your development is going forward a lot. Very good. So any questions or were we too quick? You never know if we lost some people. I can say that we would really like to have a customer in Sweden. So if someone wants to do this and try this, we can actually offer like a risk-free implementation. You will not pay anything for the software before we have implemented successfully. So then we will only pay for our hours that we use to implement it in your system. So that could be something to make someone take a decision to try this.
If no question, then I guess Eric, it's your turn.
Yeah.
We're finished.
Is there any question to Draga? Everything seems to be clear. Everything okay.
Yeah. So we have a lot of functionality, and we are very nerds on these things. But if you go to our webpage, it's more high level, and you can maybe see what's actually our solution is about. And feel free to reach out to me, so you can. I can put my phone number in the chat, and you can call me.
Okay, if there are no questions, maybe we should close then. And thank you both for both Cadmatic and Semantum and Draga for this presentation. Thank you.
Yeah.
Thank you for
Eric.
the opportunity. Thank you.
Yeah.
Yep. Bye-bye then.
Bye-bye.
Bye-bye. Have a good day.